In the last lesson, we saw how to create function templates so that we can make functions generic so that they will work with multiple data types. In this lesson, we're going to see how to do the same thing with a class and a class definition. So let's get started. The first thing we have to do is define our class. And what we're going to do is we're going to create a very minimal class to implement stacks. So to do that, we're going to assume that we're storing integers on a stack. So we're going to have a data store to store the data. It's an int. And then we also have a variable called top, which is going to be used to keep track of where we are in the stack. As you may or may not know, the stack is a last in, first out data structure. And items that are put on a stack through a process called push, the last one on would be the first one taken off the stack through a process called pop. We're using an array to store the elements, and so we use top as a variable to keep track of where the top of the stack is. We've already declared our private section. So for our public section, first of all, we're going to have a constructor. What it will do is it will set top equal to -1. I'll explain how that works in just a moment. And that's all the constructor really needs to do. Then we're going to have a void function push that will increment top by 1. That will give us the next open position in the array, and then we'll store the number that we are trying to put on the stack in that position. We'll also have a pop function that will simply return the item. We can make this a data returning function or not. I believe I'll make it data returning. It could also be void. We'll make it data returning in this particular case. So what happens here is we're going to decrement top by 1. Actually, let's do it a different way. Pop can only return the item that's at the top of the stack. So we're going to say that, then we're going to decrement top by 1, and then we're going to return val. I needed to store the top element into a variable before I decremented top, and then I can just return what's in val. That will be what comes off the top of the stack. Just to have it here, we probably won't use it, at least not in this particular case, is peek, and peek will simply show us what's on the top of the stack without actually removing the element. And that's all we need to get started. That's not a complete implementation of a stack, but it will work for the purposes of this demonstration. So we can say stack numbers, and we can say numbers push 12, numbers push 22, and so on. Just to check things out, we'll peek, we'll pop. Oh, here we're going to have to do something with that. Int value equal numbers dot pop, although we're not going to do anything with that return value. It's just there. And then we can peek again, so we'll just copy and paste that code. And all I'm doing here is just verifying that the stack works as I built it. So we'll run this code real quick, build and run. So we pushed on 12 and then 22. We took a peek at the top, that was 22. Then we took a peek at the top again after we popped off the top, and we got 12. So that's correct. Now, here's the problem with the stack class. The data store that's storing the data is declared as an integer array. So if I want to use some other data type, I can't because I've committed the stack to storing only integers. So what we want to do is, like with our functions in the previous lesson, use a template so that we can determine the type of the stack and the type of the data that's stored on the stack when it's time to actually use it. So the way we do that, it's very common to how we did it with functions, is we're going to use template, type name, t, just like we did before. And then any place that we need a reference to a type, we'll replace that reference with t. Now, of course, int top can stay the same because that's just a number that we're keeping track of. But right here, where pop returns an int, we're going to have it return a t, and peek, where it returns a int, we'll have it return a t. So now let's see how we would actually declare the stack. And just like with vectors, all we do is provide the data type after the name stack. So if we want an int stack, we put int right here. Let's build and run. You see that it works? And it does. We have the same result. Let's change it to double and try it again. And again, it works just fine. So that is how you create a template class. you simply add the keyword template, type name of T, and then any place we need a data type that's T, we simply use the placeholder rather than a specific data type name. And then at compile time, when we declare the type in the declaration, the compiler will replace T with that data type. Now there is one problem with this implementation. What if we want to use strings? Strings work fine except one problem. I didn't clear out before, right here, the element in the top. And I didn't do that on purpose because I wanted to show you with the effect. Before we decrement top, we need to clear out what's stored in top, because top is just a variable. It's just an index number. We don't want to keep a value that we've stored in the stack after we've popped it off. So where that value is stored in the array, the underlying array in data store, we need to remove that, or at least set it back to the array's default value. So we can set that value equal to 0. And that works great for numeric data types. But what if we're working with strings? If we are trying to work with strings, then the whole implementation will fall apart, because when we get to this line, when we try to store a number, 0, in a string array, we're going to have an error. But there is a solution to this problem, and we're going to look at it in the next lesson, and that's called a template specialization, or a class template specialization. So we're going to see how to modify our stack class with that specialization in the next lesson.